Welcome back to the Restaurant Payment System Project solution video. How did you get on in building out the restaurant payment system? Now, no project is plain sailing and you're bound to have come across issues when creating the application. You may have found that widgets weren't placed exactly where you wanted them to, maybe the functionality wasn't performing the way you wanted it to, but just remember that there are thousands of contributors to the Python community where solutions to your specific problems may have already been suggested. You may find these solutions online, and a great place to start is to simply enter your problem into Google. Now, this is where knowing what to Google comes in handy. So the more you pick up these concepts and the terminology and the syntax nuances when working with specific modules, you'll find that it's easier to find potential solutions to the problems you face. I'll admit that when I created this restaurant payment system for the first time, I also run into issues. I had to read the error codes and debug these issues, and I was having to Google fixes to the problems that I was facing on numerous occasions until I came up with a working solution. This can be frustrating, but just know that every developer goes through the same process. Now, you may think that the more you learn Python, the less you'll have to Google, but this isn't the case. The more you learn Python and the more advanced you get, the more complex the programs that you build will become. And guess what? You'll be Googling even more. So just understand that this is just part of the process and it's not a sign that you're not progressing with your Python learning. So let me show you how I built out this restaurant payment system application. The first thing you'll notice is that I'm coding this solution inside Visual Studio Code. And every time I want to see what this program looks like, I will be executing our application in the command line. This can obviously be built in Jupyter Notebook, but my intention after creating this solution would then be to create an executable which is then scheduled at the time when the shop opens. So I've simply decided to use Visual Studio Code as my editor of choice. So the first thing we need to do is design the restaurant payment system layout. So the template I shared in the last video looks something like this, and this can be broken down into 3 frames. We first of all have the top frame, which stores the title information. We then have 2 other frames, one on the left and one on the right, with the left frame hosting the inputs and the respective bill calculations and other functions, and the right frame contains the calculator that we created in the last section. So let's get started and create this structure. So the first thing we need to do is from tkinter import star, and then we can create the master app window. So we can create a variable called root and set this equal to a call on the tk class. We can then set the size of this application, so I can put root.geometry, and then inside parentheses, I'm going to set the size of this application to be 1400 pixels width by 700 pixels in height. I then want to give this application a title. So I can put root.title, and then in parentheses, I can pass in the string restaurant payment system. So this will give us a single app window with a title called restaurant payment system with 1400 by 700 as its size. I'm now going to create the 3 frames in which we will then place our widgets. So I'm going to first of all create the top frame. So I'll create a variable called top, and I'll set this equal to a call on the frame class. This frame will be placed inside the main app window, which we know we've stored in the variable root, so root will be the first argument. I want the top frame to span the whole width of the application, so I'll set the parameter width to be equal to 1400, and because we want the top frame to only be a small section at the top, I'm going to set the height of this frame to equal 50 pixels. I'm then simply going to pack this frame into the application. So I'm going to put top.pack, and then inside parentheses, I'm going to state that the side should equal top. And this will just place this frame at the top of the window. We can now create our left-hand side frame. So I'll call this frame frame 1. I can then set this equal to a call on the frame class. We will once again place this within the main app window, which we've stored in root. I want the width of this frame to be a little bit more than halfway, so I'm going to set the width to equal 900 pixels. And I want the height to be the remaining space within the application. So I can put height and set this equal to 650 pixels. When added to the top frame, this will span the entire application window. I can then pack this frame into the main window. So I can put frame1.pack, and then we can stipulate that we want the side to equal left. So this will be placed on the left hand side. And finally, we need to create that right hand side frame so we can place our calculator in there. So we'll call the right hand frame frame2. We'll set this equal to a call on the frame class. Our first argument will be the root variable that we've classified above. The width of the calculator will be slightly smaller, so we'll put width equals 400. And once again, we want it to be the remaining height after we've placed that top frame in the window. So our height will also equal 650. We can then pack this frame into our main app window. So we'll put frame2.pack, and inside parentheses, well, we're going to put side equals right. So up until this point, we will have a blank application with 3 frames. So if I put root.mainLoop with parentheses, and then inside of our command prompt, we execute the program inside the folder location where we've saved this file. When we do this, we get a 1400 by 700 application with the title Restaurant Payment System. And I know it's not obvious here, but we have 3 frames that we've created, and they would look something like this. Let's now populate our top frame with some information that would be useful to Foodie Limited. So we'll first of all place a title within the application. So we're going to create a variable called app_title, and we're going to set this to a call on the label widget class. So we'll put label and then parentheses. Now we want to place this label widget in the frame which is labeled top. So the first argument that we pass in will be top, because we want the label widget placed in this top frame. We can then put a comma. We will then set the font for this title. So we'll put font equals, and then we'll open up normal brackets to place information inside of a tuple. The first element will be the font name, so we'll put Arial. We'll then put a comma. We want it to be quite a big title, so we'll put the integer 30 as the second element, and we want the title to be bold, so the third element will be the string bold. I can then put a comma, and then we can set the text for this label. So we'll put text equals, and we'll call this Restaurant Payment System. We can then place this widget using the grid geometry manager, so we can put app_title.grid, and we can place this in the top row, so we can set row to equal 0, and then we can put a comma. And because this frame will only be made up of one column, we can simply put column equals 0. So because the top frame will only be made up of one column, this will place the title in the middle of the frame. And just to make this frame a little bit more interesting, we're going to add a date and time which allows a user of the application to see when the application was opened. And to help us achieve this, we're going to import some logic from the time module. So we're going to go back up to where our imports are, and we're going to put import time. I can then come back down, and I'll set a variable called local time, and I'm going to set this equal to the module time, and then I'm going to call upon the method ASC time. Inside parentheses, I'm then going to once again call upon the time module, then place a dot, and then access local time. To get the respective time, I can now, in the local times methods parentheses, I can put time.time and execute that method. This will now store the time on my machine in a variable called local time, which we can now use in our application. In the resources section, I have added some material that dives into the time module in more detail, if you're interested in taking this learning further. So let's now add this local time to our application. We can create a variable called app_time, and I can set this equal to a call on the label class, because we'll be placing our local time within a label. We want this label to be placed in the top frame, so our first argument can be top. We can then put a comma. We want the font of this time to be the same font name, so we'll put Arial, but this time we want it to be slightly smaller, so we'll have a second element in this tuple as 20. And we won't be making this bold so that it doesn't stand out as much compared to the title. We can then put a comma. Now the text for this label, we can simply set this equal to our variable called local time. So what will happen is, as this program runs, it will first of all store the local time in this variable, and then it will be placed in the label. We now need to place this app_time label inside the top frame, so we can put app_time.grid, and this time we want it to be on the second row so that it's underneath the main title, so we can put row equals 1. And because we've only got one column that we're working with in the top frame, we'll set column to equal 0. So up until this point, if I save and then rerun our application, you can see that we've now added a title at the top. You can see that we've got the date and time respectively underneath the title, and this has all been placed in the top frame. Great. So let's now move on and see if we can get our calculator placed on the right hand side. We've already created the logic for our calculator, but if you remember from the last video, I set you a challenge to see if you can get the calculator in this application without rewriting the code. I simply want you to call a function in this application that brings back the calculator from a different file. A little bit tricky because we haven't seen this in a project yet, but let me show you how I achieved this to get the calculator working. So my first thought was to import a module called calc_function. Now we haven't created this module yet, but I'm going to put this here because this is the module name I intend to create. And then what I want to call within this application is a function from the calc_function module. So I want to put something like calc_function, and I'll assume that I'm going to be creating a function called calculator. So I'll put .calculator and then I'll put parentheses because we're going to be calling this method. I'm now going to go across to the my_calculator.py file that we created in the last section. Now this file works in its own right for the calculator, but I want to be able to call a function from our restaurant.py file rather than rewriting all of this code. So I do need to tweak it slightly in order for this to work, but we don't have to make too many changes. So I'm going to save this file as a new name, and we know that we need this file to be called calc_function, because that's the name of the module that we are importing in our restaurant.py file. And I need to make sure that this is saved down in the same location as the restaurant.py file. Now we've already created the app window and the respective frames in the restaurant.py file. So in the my_calculator.py file, we won't need to set these again, so we can delete our references to the variable root. But what we do need to do is create a function called calculator, because in our restaurant.py file, it's a method called calculator that we're calling upon when we import the calc_function module. So we'll put def calculator and then we'll put parentheses. Now all the code underneath we need to indent by 1 tab to comply with the code body of a function. Now the next consideration is that when we call calculator, we don't know what frame we're going to be placing this in our application. At the moment, if I scroll down, you can see that the text display, the button clear, the button bracket 1, they all reference the app window root that we've just deleted. So without knowing what the frame will be, we can pass in a parameter called frame, which we'll expect to populate within our restaurant.py file, and then I can replace the variable root for the variable frame. Now with this done, our function now has one parameter that needs to be populated. And we know that we want the calculator to be populated within the frame2 window, which sits on the right hand side of our main app window. So in parentheses, we want the frame to be frame2. So this now means that the first argument that's being passed in to our entry widgets, to our button widgets, is frame2 when we call the function from our restaurant.py file. And the last change we need to make is with respect to the keyword global. Now where we've put global, we need to change this keyword to non-local. And the reason being, our functions defined in this calculator function are nested functions. And we need them to access the variables that are defined above here in the outer scope. And the non-local keyword is used to work with variables inside of nested functions. So we use the keyword non-local to declare that this variable here is not local, it's actually found in the outer scope, i.e. here. Now at the bottom of this calc_function.py, you can see that we're calling frame.mainLoop. But because we're calling the function in the restaurant.py file, we don't want to call the frame.mainLoop here, as this will be done at the bottom of the restaurant.py file. But what we do want to return when this function is called is the frame that's created. So at the bottom we can replace frame.mainLoop with parentheses with return, and we want to return the frame. If I now save this file and rerun the application, you can see that we have the top frame populated with our title and time, and we've now populated our frame 2, which is that right hand frame, with the calculator that we created in the prior section. We haven't copy and pasted our code, we've simply imported our code that was written with a few tweaks and then called upon that function inside of our restaurant.py file. If there's another application that you want to build out and you want this calculator app inside, all you need to do is call upon the calculator method from within the calc_function module that you've created. Okay, so let's now move on to populating our left-hand frame. And if I just bring back up the template to jog our memories as to the layout that we're trying to achieve, just like we did with the calculator, we're going to create the widgets without the functionality. It's going to be the building blocks of how it looks so that we can click the buttons and we can enter information, but nothing will happen upon a click of a button. So these boxes here look very similar to the top box of the calculator. So what do we need to create? Well, we need to create entry boxes for these items, and we know that the information is stored in these entry boxes as a string, and the placeholder for this string will require a call on the string var class, which constructs a value placeholder for these string variables. So we've got 12 in total that we need to create. So we'll first of all create a variable called fries and set this equal to a call on the string var class, and we'll do the same for large fries. We'll do the same for the burger. We'll do the same for the Filet-O-Fish, the cheeseburger, the drinks. We need one for the order number. We need one for the cost, the service charge. We need one for tax, subtotal, and finally total. So with these placeholders now set, we can create the respective labels and entry boxes for each of these items. So the first one we'll do is fries. So we'll create a label for fries called label fries, and we'll set this equal to a call on the label class. We want this passed into frame 1, which is that left hand side frame. We want to set the font to equal a tuple with the font name Arial. We want it to be size 16, and we want it to be bold. We'll then set the text of this label to be fries. I can then put label fries.grid, and inside of frame 1, we want this to be placed in row 0, so the first row, and we want it to be placed in column 0, so the first column. We can then place an entry box next to it, so we can create a variable called text fries, and we'll set this equal to a call on the entry class. We once again want this passed into frame 1. We want the font settings to be the same as the label settings, so we can copy and paste this. We now know that the entry box text variable is going to be set equal to fries, which is that placeholder that we've created above, in a very similar way to how we constructed the calculator. We'll provide the entry box a small border so we can set BD to equal 6. We want the background of this entry box to be white, so we can put BG and set this equal to the string white. And when a staff member puts in a number here, we want the number to appear on the right hand side of this entry box. So we'll set justify to equal right. We can then place this entry box into the frame, so we can put text fries dot grid. We want it to be on the first row, so it sits next to that fries label, so row equals 0. But this time we want it to sit alongside it in column 2, so we can set column to equal 1. Now to speed things up, I'm going to copy and paste both the label fries and the text fries, and I'm going to change the label to state label large fries. I can then change the text of the label to be large fries. This time I want the large fries label to sit underneath the fries label, so I need to change row to equal 1, and we still want it in that first column, so column equals 0 still. We can then change text fries to be text large fries, and what we need to change here is the text variable to point to the placeholder for the large fries, so we can put large fries, and we want this to sit next to the large fries label, so we can change row to 1 and column to 1. And just to speed things up so you're not looking at repetitive coding, I'm going to copy and paste this numerous times, change the label text and the text variables accordingly, and I'm going to change the row and column for which I want the labels to sit. Okay, so I've now made it down to drinks. We can now create the second lot of boxes that we can see here, and the reason I've coloured them in blue is because this is where I expect output to come. I don't expect any user input into these boxes, I only expect output to be shown within these boxes. But to create these labels and entry boxes, it's exactly the same. So I'll create a label called label order number, and I'll set this equal to a call on the label class. We'll pass this into frame 1. We want the font to be exactly the same as the other labels. We want the text to equal order number. And we're going to set the foreground colour of this text to equal steel blue to give it that nice blue colour. I can then put label order number dot grid. I want this to sit on the first row of this specific frame, so row equals 0, and I want it in the third column. So I'll set column to equal 2. I can now create the entry box, so I'll put text order number, and we'll set this equal to a call on the entry class. We'll pass in frame 1. We'll pass in the same font. We'll set the text variable to equal order number. We'll have the border as 6. We want the background this time to equal powder blue to give it the same type of blue in the template that I showed you. And once again, we'll set the justify property to equal right. We can then put text order number.grid, and we'll place this in the first row, so row equals 0, and the fourth column, so column equals 3. So really the only things changing here are the foreground of the text to steel blue and the background of the entry box to powder blue. I will now copy and paste this numerous times and create the labels and respective entry boxes for cost, service charge, tax, subtotal and total. Okay, so if I run the application as it stands now, so if I save this file and run the application using our command line, you can see that our restaurant payment system is starting to take shape. We still need to produce those buttons, so let's do that next. Hopefully you're very familiar with how we create buttons, so there should be no problems with what I'm about to go through. I'm first of all going to create a quick label just to provide some space between where it says drinks, then the entry box, and total and the entry box, so that the buttons are a little bit further below. And to do this, I'm just going to create a label, so I'll put label total, and I'll set this equal to a call on the label class. We'll put this in frame 1. I'll set the text just to equal a little dash so you can't really see it. And I'm going to set the foreground to equal white, so it blurs into the background and it's hardly noticeable. I'm then going to place this in the frame, so I'll put label total dot grid, and I want this to be underneath the drinks and the total line, so I need to have this in row 6, and I want the column span to equal 4, because we have 4 columns in total within this frame. So this is just to provide us some space. I can now create the buttons. So the first button I'll create will be called button price. I'll set this equal to a call on the button class. We once again want to place this in frame 1. We're going to provide some padding to make the button look a little bit bigger, so we'll put pad X and set this to 16. We'll set pad Y to equal 8. We're going to provide these buttons with a border, so we can set the border property BD to equal 10. We'll set the foreground to equal black. The font will be the same as above, so we can copy and paste this. We'll set the width to equal 10. We're going to set text to equal price in capital letters. And we want the background of the button to equal the string powder blue. Now we will be placing a command on this shortly, but seeing as we haven't written the function for this yet, we're going to leave this for the time being. We can then place this button in the frame, so we can put button price dot grid. We want this in row 7, so underneath the little dash that we've used to create that space. And we want this button in the first column, so we can put column equals 0. Now seeing as I've created that first button, I can simply copy and paste this button 3 more times, and all I'm going to be doing is changing the text to be total, reset, and exit. And we just need to make sure that these buttons are placed alongside each other, so we also need to change the columns to be 1, 2, and 3, so that they sit in columns 2, 3, and 4 respectively. Great, so if I now save this and take a look at our application, we've created the skeleton for our inputs and outputs, and we have these buttons, which when we click do nothing for the time being. So all we need to do now is create some functions which are then executed so that the app comes together. So let's now go and create these functions accordingly. Now the first function I want to create is with respect to the total button. When a staff member clicks on total, we're going to expect it to observe how many items of each food category they've ordered, and then we're going to need to multiply this by the food's price. We're also going to want it so that the order number is automatically generated, and we can just have this as some form of random number of 5 digits. So let's go ahead and tackle this function. Once again, you can implement this however you like. What I'm about to take you through is just a way that you could have gone about doing this. So we'll create a function called bill, and we'll then put parentheses with a colon. We'll then create a variable called x, which will set equal to random.randint, and inside parentheses we'll pass in 2 numbers to give us a 5-digit order number, so we'll put 10,000, 99999. And here, because I'm trying to access the randint method from the random module, we are going to need to go back up and import random so that we can use this method accordingly. I then want to convert this into a string so it can be placed within our entry widget, so we can wrap this within the built-in str function. And because we want the order numbers entry widget's placeholder that we've created above to be set to the value x, we can put order number dot set, so utilizing that set method that we saw when creating a calculator, and we can then pass in the variable x. Great, so that should deal with the order number box when we then associate this specific function with the command for the order number entry box. But let's now move on to the calculation of the bill. So the first thing that we're going to need to do is observe how many items are being ordered by a customer. So when the staff member puts in an integer into these entry boxes, we need to store this integer in a variable. Now you've seen how we set information in an entry box. We use the set method. The way we get information from an entry box, in this case the number of items that they've ordered, we can use the get method. So I can set a variable called count of fries and then set this equal to the placeholder that's storing the string value, which in this instance we've labelled as fries, as can be seen here. We can then use dot notation and utilise the get method, so we can put dot get and then parentheses. Now seeing as this is a string to begin with and we're going to want to use this in a multiplication, we're going to convert this into an integer by using the built-in int function. I can now copy and paste this line of code, and for large fries we can change the variable to count of L fries and change the value holder to be the large fries variable. We can then copy and paste the code once again and change the variable to be count of burger, and then we can change the value placeholder to be the variable burger. We can do the same for the filet of fish, so count of fillet and change the placeholder to fillet. We can do the same for cheeseburger, so we'll put count of cheese and then we'll change this to cheese_burger. And finally we can store the count of drinks, so we'll put count of drinks and set this equal to the drinks placeholder. So once again, when a user places an integer into these boxes, the value that's placed in will be stored inside of these variable names. We can now multiply these integers by the respective cost of each item. So we need some form of data structure that will be good to store price information. What data structure do you think is a good option? Well, the data structure that I've opted for is a dictionary because we have key value pairs, and I'm thinking here that the key can be the food item's name and the value can be the cost associated with that item. So just above this function definition and below these variable definitions, I'm going to create a variable called price_list, and I'm going to set this equal to a dictionary. The first key will be called fries, and we'll have the associated value to be £2.50. We can then set a second key called large fries, and large fries can cost £3.50. We can set a third key called burger, which we'll have set at £5.50. We can have a fourth item called fillet, which can have an associated price of £4.50. We can then put a key labelled C burger for cheeseburger, and this can cost £6. And finally we can have drinks, and the drinks will all cost £2. So we have the number of items ordered that are now stored in these variables, and we also have a price list, which is a dictionary telling us how much each item costs. So I simply need to multiply one by the other. So let's first of all work out the cost of fries. So we can put cost of fries as the variable name, and we can set this equal to count of fries, and we can then multiply this and access the price for fries. So we can put price_list, which is that dictionary, and inside square brackets we can pass in the key name, which we know is fries. I can now do the same for cost of large fries, for the burger, for the filet of fish, the cheeseburger and drinks, and simply change the count variable to the respective variable, and then change the key that's passed into the square brackets of the dictionary so that we get the respective price for the item. And what this will mean is that the function then stores the cost of these items into these variable names respectively. We can now create the calculations for the other entry boxes such as cost, service charge, tax and so on. So the first thing we'll do is create a variable called cost of everything, and this will simply be the sum of each of the variables above. We can then create a variable called cost of meal, and I'll set this equal to the pound symbol as a string, and we'll then plus a call on the built-in string function in which we'll pass in a format, so we can put inverted commas, %.2f, and outside of the single quotes we can place a percentage. I can then reference the value that we want formatted, so I can pass in cost of everything. If you're interested to know about the different types of string formatting you can do using similar syntax, I've attached some material in the resources section. I can now create a variable called pay tax, and this will simply be a calculation of the tax that the customer needs to pay. So we can put cost of everything, and we'll simply say the tax is a fixed 10%. We can then have the total cost variable set equal to the cost of everything plus the tax payment, so plus the pay tax variable. We can then have a variable called service_charge, and this can be equal to a calculation on the total cost multiplied by 0.125, so a 12.5% service charge. I can then create a variable called service, which we'll set as a formatted version. So we can put the £. We can then plus the string with the same format, but this time pass in service_charge. I can then set a variable called overall cost, and I can set this equal to a £. We'll then plus the same string function with the same format, and the overall cost will be total cost plus the service_charge. We can then finally create a variable called paid tax, and we'll set this equal to the £, and we'll plus the built-in string function, for which it will have the same format, but this time reference the variable pay tax. Now, to get these formatted strings into the respective entry boxes, we just need to set the placeholders for which we've defined. So we can put service_charge, and we can then use the .set method and set this equal to the variable service that we've just created above. The cost placeholder we will set to the cost of meal variable. The tax placeholder will be set to the paid tax. The value holder for subtotal, we will set this also to the cost of meal. So a little bit redundant in this example, but we'll just go with it. And then the total we will set to the overall cost variable. So at this point we've created our function. We now just need to associate this function with the respective button once it's clicked. So if we scroll down to where we've defined the total button, we can then pass into the button class the keyword command, and we can set this equal to the function labeled bill. Now notice here we're not using the lambda expression because we're not passing in any parameters into the bill function, so simply putting command equals bill should work fine. If I now save what we've got here and then run our application, if I now input an order into the white boxes, so let's put 1 for fries, 3 for large fries, we'll put 4 for hamburger, 5 for filet fish, 4 for cheeseburger, and we'll have 3 drinks, so a large party at this restaurant. When I click total, you can see that we're given a random order number. The cost is £87.50, there's a service charge of £12 and 3p, tax is £8.75, subtotal is £87.50, and we've got a total bill of £108.28. So our calculations are feeding in just like we expect, the format looks good, and we've now got a working payment system for these respective items. So great work. Now the other buttons admittedly do not work yet, but these will be simple to produce. So let's go back and create the function for the exit button. Here we can create a function called exit, put parentheses and a colon, and we simply want the application to close when this button is clicked. And the way we do this is by calling the destroy method on the app window. So we can put root.destroy with parentheses. We can now go down to where we've defined the exit button. We can add the keyword command, and we will simply set this equal to the function exit. Great, so very easy, no need to test this just yet. So let's scroll back up and we'll now define the function for the reset button. So we can put def reset with parentheses and a colon. And here what I'm going to do is copy and paste all the placeholders where we've set them equal to a call on the string var class. But rather than setting it equal to a call on the string var class, I'm simply going to call upon the set method for all of them and pass in an empty string. This means that when the reset button is clicked, the value holders will be set to an empty string and everything will appear blank within the application. I can then assign this function with the reset button, so in the button class I can add the command keyword and I can set this equal to reset. Once again, no need to include the lambda function here because we're not passing in any arguments to our defined functions. Now we're on to our final button, which is the price button, and my intention here is to have it so that when we click on price, we're presented with a little window which shows the staff member how much each item costs, just in case a customer asks and the staff member forgets. So we'll first of all define the function called price. We can then put parentheses and a colon. And the first thing I'm going to do here is create a new app window, a new master window for which the price information will sit. So I'll create a variable called r and I'll set this equal to a call on the TK class. Now I want the little pop-up to be quite small, so I'm going to set the geometry of this app window, so r.geometry, to be 600 pixels by 220 pixels. I then want to provide this pop-up with a title, which will be labelled Price List. I can now go ahead and just create a list of labels which shows the item name and a list of labels which shows the item price. So I'll create the first couple and then I will simply copy and paste and change the code slightly so that it's relevant for each food item. So we can put label info equals a call on the label class. We want this placed in the app window labelled R. We want the font to be the same above, so we can put font equals and then a tuple with the font name Arial. We'll have it so the font size is 15 and we'll have it so the font is bold. We'll have it so that the list of items has a title labelled item in capitals, so we'll set text to equal item, and we want it so the text is black, so we can set the foreground to equal black. We can then place this in the app window, so we can put label info.grid, we'll have it on the first row, and we'll have this title in the first column. Now the second column in this price list will obviously be the price next to the item, but just to give it some space in between, we'll once again put a dash to provide that space accordingly. So we can copy and paste the above code. We'll change the text to be an underscore as it's a little bit bigger than a hyphen, and we'll set the foreground to white so it's barely noticeable on screen. We want this to appear in the top row and we want this to appear in the second column. So we'll change column to equal 1. We can then copy and paste this code. We'll change the text to equal price. The colour of the font we'll want as black. And we'll have it so the price label is anchored to the west of the label. So we can set anchor to equal W. Seeing as we want this to be in the first row and the third column, row can be left as 0 and column can be set as 2. Now I'll create the price list for fries so you can see an example, but then I'll speed through this so we don't have to watch repetitive code. So I'll once again copy and paste the above code. I will change the text to equal fries. I will set the foreground to equal steel blue to give it a change of colour so we can distinguish it from the title. And I'm then going to place this in the second row and in the first column. So row will equal 1 and column will equal 0. I can copy and paste this code. And this time I want the text to equal the price of the item. So I can set it equal to a £sign in double quotes, and I can then plus the built-in string function, pass in a 2 decimal figure string format. I can then access the price list, which is the dictionary that we set above, and I can pass into square brackets the key fries. I want this placed on the second row, so I can set row to equal 1, and I want it placed in the third column, so I can set column to equal 2. Now, seeing as this is its own app window, I'm going to end this function as it stands now with r.mainLoop with parentheses, and then down where we've defined the price button, I'm going to add a command which calls upon price. So if I now save this file and rerun our application, when I now click on the price button, you can see that we get a new pop-up window which has our item and price. And we can obviously extend this so that it has every single price for every item by simply copy and pasting what we've just done for fries and calling upon the respective key from that price list dictionary. But in the interest of time, I'm going to leave this and we now have a fully functioning application. The staff member is able to use a calculator if they need to do some simple arithmetic. They're able to input the number of items that the customers are ordering. They can hit total and the respective bill total will appear within the blue entry boxes on the right hand side. The staff member can click price, which will inform them how much each item costs if you were to expand on the price function. We can hit reset, which will set everything to a blank string. And once the staff member has finished using the application, they can click on the big exit button and the application will close down. So once again, we've covered a tremendous amount of content here, specifically utilising the tkinter package. We created a calculator and now we've just created a restaurant payment system. These skills that you're picking up can be used in so many different scenarios. For example, at your workplace, you can create an application that does stuff and produces output based on specific functions, and you can pass your application to others to use if you think they'd find it useful. Don't underestimate how much you've learned here, it's a tremendous amount, so well done for getting this far if you're still with me. We've still got so much exciting content to cover in this course which I can't wait to share with you, so I'll see you in the next section.